So in this situation, we have a steel sphere that has a mass of m, moving along at a constant speed v, identical sphere b, so it has the same m, is at rest, so v0 equals 0. Also, omega 0 equals 0 because it's stationary. Has a length, radius r, it's suspended by, collide. So we should recognize this is a ballistic pendulum. Ballistic pendulum. Sphere A stops and sphere B swings to a vertical height h. So some height h, B goes up to, like so. So we know this gravitational potential energy would equal this kinetic energy down here. And we know this is a conservation of momentum situation. We know, since this stops, that if we have P0 equals P, beforehand we have the momentum of A, and afterward we're going to have the momentum of B, because A comes at rest. So initially, this has a V0 equals 0, and afterward this has a V equal to 0. So momentum of A equals momentum B. We resolve that. Okay? And so that means that initially the kinetic energy that B has will be exactly the same as, kinetic energy will be exactly the same as A. So EKA will equal EKB. All right, so those are interesting things to know in terms of this collision. As it rests, hangs on a string, the spheres collide, A stops, B swings, comes to the top where it's momentarily at rest. Knowing the values will determine the angular impulse with respect to P. All right, so we'll do our linear comparison. Our linear comparison is our linear impulse is delta P is F delta T is M delta V. So similarly, our angular impulse will be equal to delta L, which is going to be M delta omega. M delta omega. And so it wants to know what we need to know. Well, we definitely need to know M. So this one is out. But notice it's not in terms of omega. Well, we should know that the relationship V equals omega R. So therefore, omega is V over R. Excuse me, I did that incorrectly. I know I missed something. Delta L is going to be I delta omega. And so then omega is V over R. And I is mr squared. And delta omega then is V over R. R cancels, and we're left with mrv is delta L. Now, I'd also given you another identity previously that L equals mrv. So you know that. That's an extra identity. But we just derived it right there, proved it. So we need R, M, and V. We need R. We need R. Choice D.